Hi friends, welcome back to my YouTube channel. My name is Darudam. I am studying in Sri Venkateshwara College of Engineering. Subject Introduction to Mechanical Engineering. Topic 4-stroke diesel engine and 4-stroke petrol engine. 4-stroke petrol engine. The working principle of 4-stroke petrol engine is based on theoretical Otto cycle, constant volume cycle. Hence, it is also known as Otto cycle engine. In 4-stroke engine, piston performs 4 different strokes to complete all the operations of the working cycle. The 4 different strokes performed as suction stroke and compression stroke, power stroke, expansion stroke, working stroke, exhaust stroke. The 4 different strokes are suction stroke, compression stroke, power stroke, expansion stroke, working stroke, D exhaust stroke. AB suction of air and petrol. BC compression of mixture. CD constant volume combustion. DE expansion stroke. EB exhaust valve opens. BA exhaust of combustion product. Suction stroke. This stroke starts when the piston is at TDC and about to move downwards. During this cycle, inlet valve remains open and exhaust valve remains closed. Due to low pressure created by the downwards moving piston, the charged air-fuel mixture is drawn into the cylinder. At the end of the stroke, the inlet valve closes. The suction stroke is represented by the line AB and PV diagram as shown in the figure. Compression stroke. During this stroke, the compression of fresh drawn charges takes place by the return stroke BDC to TDC of piston. During this stroke, both inlet and exhaust valve are closed. The pressure and temperature of the charges increases, and this is shown by the curve BC on the PV diagram. When the piston reaches the TDC or just before the completion of compression stroke, the spark plug ignitions the charge. The combustion of the fuel takes place at the constant volume and is shown by a line CD on the PV diagram. The compression ratio in the petrol engines ranges from 7:1 to 11:1. Power stroke, expansion stroke, working stroke. At the beginning of the stroke, piston is in TDC, and during the stroke, piston moves from TDC to BDC. During this stroke, but both inlet and exhaust valve remain closed. The combustion of fuel liberates gases, and these gases starts expanding. Due to expansion, the hot gases exert a large forces on the piston, and as a result, the piston is pushed from TDC to BDC. The power impulses is transmitted down through the piston to the crankshaft through the connecting rod. This causes crankshaft to the rotate high speeds. Those work is obtained in the strokes. Hence the rotation of high speeds, the work is obtained in the stroke. Hence the rotate at high speed, the work is obtained in a stroke. Hence this strokes is also called as working stroke. Also gas expands and thus the stroke is also called working strokes. The expansion of gases is abundant in nature, and this is shown by the curve DE on PV diagram. As the piston reaches the BDC, the curve DE PV diagram. As the piston reaches the BDC, the exhaust valve opens. A part of burn gases escape through the exhaust valve out of the cylinder due to their own expansion. Exhaust stroke. At the beginning of the stroke, piston is in BDC. During the stroke, the piston moves from BDC to TDC. During this stroke, inlet valve is closed and exhaust valve is opened. As the piston moves upward, it forces the remaining burnt gases out of the cylinder to the atmosphere through the exhaust valve. This is shown by the line EB and BA on PV diagram. When the piston reaches the TDC and the exhaust valve closes, and this completes the cycle. In next cycle, the piston which is at TDC moves to the BDC, thereby allowing fresh charges to enter the cylinder and process the continuous. This is the 4-stroke petrol engine 3D working. 4-stroke diesel engine. The working principle of 4-stroke diesel engine is based on theoretical diesel cycle, hence it is also called as diesel cycle engine. Suction stroke, compression stroke, power stroke, exhaust stroke. This is the PVC diagram of 4-stroke diesel engine. AB suction of fresh air, BC compression of air, CD constant pressure combustion. At D fuel supply cut off, DE expansion stroke, EB Exhaust values opens BA exhaust of combustion product. A suction stroke. At the beginning of the stroke, piston is in TDC and during the stroke, piston moves from TDC to BDC. During this stroke, the inlet valve opens and the exhaust valve will be closed. The downward movement of the piston creates suction in the cylinder and as a result fresh air is drawn into the cylinder through the inlet valve. When the piston reaches the BDC, the suction stroke complete. This is represented by the line AB on PV diagram. Compression stroke. At the beginning of the stroke, piston is in BDC and during the stroke, piston moves from BDC to TDC. During this stroke, both inlet and exhaust valve are closed. As the piston moves upward air, the cylinder is compressed to high pressure and temperature. The compression pressure is abatic in nature and is shown by the curve BC in PV diagram. As the fuel comes in the contact with the hot compressed air, it gets ignited and undergoes combustion at constant pressure. This process is shown by the line CD on PV diagram. The compression ratio ranges from 16 is to 1 to 20 is to 1. Power stroke, expansion stroke and working stroke. At the beginning of the stroke, piston is in TDC and during the stroke, piston moves from TDC to BDC. During this stroke, both inlet and exhaust valve remain closed. As combustion of fuel takes place, the burnt gases expand and exerts a large force on the piston. Due to this, piston is pushed from TDC to BDC. The power impulses is transmitted down through the piston to the crankshaft through the connecting rod. This causes the crankshaft to the rotate at high speeds. Those work is obtained in this stroke. The expansion of gases is abatic in nature and this is shown by the curve DA on PV diagram. When the piston reaches the VDC to exhaust valve opens, a part of burnt gases escapes through the exhaust valve out of the cylinder due to the self-expansion. The drop in the pressure at constant volume is shown by the line EB on PV diagram. Exhaust stroke. At the beginning of the stroke, piston is in BDC and during this stroke, piston moves from BDC to TDC. During this stroke, the inlet valve is closed and the exhaust valve is opened. As the piston moves upward, it forces remaining burnt gases out of the cylinder through the exhaust valve. This is shown by the line BA and PV diagram. When the piston reaches the TDC and the exhaust valve, this complete this cycle. In next cycle, the piston which is at TDC move to BDC, thereby allowing fresh air to entering into the cylinder and process continuing. Thank you for watching.